Alright, good morning. This is e-learning day for April 1st, Honors Math 3. Alright, so we're going to be using this note sheet for today. I'll give you a moment to take a look at the first few examples, which again are review problems. Since we started this module on sequences. For number one, it was a word problem situation where you were asked to find out how much is in the bank after saving a certain amount of money per month. And you want to start off by creating this explicit, noticing that it's an arithmetic, because we're adding the same value each month. So you have an initial value of $500 to start the account, and we're adding $60 each month, where N is going to represent how many months we're saving. Okay, so using that explicit, right, a year and a half is 18 months, so we plug 18 in for N, and we get $1,580 saved after 18 months. Problem number two, both parts A and B, again, are using those summation properties and formulas. Again, I did not get a lot of questions on these, so I'm hoping that everything was good. And if not, then make sure you guys are emailing me, letting me know where I can help. Number three, we're given that sequence, noticing the patterns that we're adding 4 each time. So part A is asking us to find the sum of the first 57 terms. So here again I wrote it as an explicit, fitting the pattern, kind of simplify that explicit expression. Again, I'm using the summation setup here for this one. So I want to sum up terms from the first term all the way up to the 57th term. Again, I use this method to demonstrate more examples of how to use those properties and formulas for summation. Okay. Part B, you're asked to write the recursive formula. So again, we'll call it recursive. You got to give a statement of like some terms. So here we're given the first term, -5, and find the next term in the sequence. You just take the previous term and then add 4. Alright, so today's lesson, again, we're just going to review the concepts of the geometric sequences that you'll learn in Honors Math 1. So here we're given an example of geometric, which again, reminder that when a ratio of successive terms is a sequence, the sequence is always the same number. The sequence is called geometric, so ratio. So as you go from one term to the next, in this particular geometric, I'm multiplying by 3. Right? So they go from 2 to 6 times 3. 6, 18 times 3, 18 to 54 times 3. Alright, so that times 3 is the common ratio. To define it recursively, then we're going to make a statement about a term. So the first term is 2, and to find every term after that, you're going to take the previous term and multiply it by 3. Right? So that's the pattern. To get to the next term, we are multiplying by this common ratio. Looking at these examples, This first one is geometric because as I go from one term to the next, I have to multiply by the same non-zero number, which is 1/3. Right? 12 times 1/3 is 4. 4 times 1/3, 4/3. 4/3 times 1/3, 4/9. Right? So it's geometric because there is a common ratio. This next one is not arithmetic or geometric. Right? There's nothing that I can add or subtract to get to the same to the next number. There's no common difference. There's no common ratio. There's nothing that I can multiply over and over again to get to the next term. Okay, so this one's neither. Okay, so here we're going to review how to write an explicit for geometric. So again, going back to my example of where my terms were these terms to start off with for the first 4 terms. Then showing you again how the common ratio works here. Right. So as we go from the first term to the second term, I'm going to take the first term and then multiply it by that common ratio. And when I move on to the next term, the third term, again, the makeup of that third term is that I'm including the first term and I'm multiplying by another factor of the common ratio. So each time I move down to the next term, I am multiplying by another factor of the common ratio. What we notice here is that the number of times we see the common ratio being used is always going to be 1 less than the term number. So here the term number is 2, but I'm multiplying by the common ratio 1 time. Here the term number is 3, I'm multiplying by the common ratio twice. Term number 4, here I'm multiplying by the common ratio 3 times. Right? So that would explain why in our generic setup for the explicit for the geometric, to find any term in the geometric, you're going to take, in this case, the first term, and you're going to multiply it by the common ratio, put to an exponent, again, because it's multiple, it is repetitive multiplication, we use exponents, times the common ratio put to the n minus 1 exponent. 1 less than what the term is. So here, for example, we're looking at this sequence. It is a geometric because as I go from one term to the next, I'm multiplying by 2 each time. That's my common ratio. So again, to find the 10th term, I'm going to take the first term times my common ratio put to the term number minus 1 as an exponent. Alright, so that gets me, my 10th term is 2,560. Now, while this generic setup for the explicit for geometric uses the first term, know that you don't necessarily have to use the first term. I'm going to show you how we can adjust this. I'd say again, I'm still looking for the 10th term. And instead of maybe using the first term, maybe I want to use the third term. So I'm going to replace this a sub 1 with a sub 3. Meaning, okay, I'm using the third term instead. There's my common ratio. Right. Now, when it comes time for the exponent, again, I'm looking for the 10th term. So n is going to be 10 but instead of minus 1, I'm going to be putting a minus 3. The reason being is because I'm now using the third term instead in this setup. Right? Again, in this initial setup, we use the first term, so then we're doing n minus 1. Here we're using the third term. Now we're doing the n value minus 3. And you're going to see that with that adjustment, we are still going to be able to get that same value for the 10th term. Okay. Alright, so that's going to be helpful when we get to the next two examples. So here we want to find, we're given the third term and the sixth term, and we want to find the 10th term. Alright, so the first thing we need to do is find the common ratio. So there's two steps in the finding the common ratio. First thing you're going to do is you're going to take the two terms you're given. Okay, so you're going to divide the latest term divided by the first term you're given. Okay, so the value of the sixth term, and then divide by the value of the third term. Okay, so when I do that, I get 125 for this one. The second step is then you are going to take that value and put it to underneath the radical. Now the index to that radical is going to be the difference in the terms, right? 6 minus 3 is 3. So that's going to be my index for my radical. So here I'm taking the cube root of 125. And when I do that, 5 is going to be my common ratio. Okay, so now I'm going to find the 10th term. So again, I'm going to use that explicit. So a sub 10, 10th term is equal to, I'm going to use the third term for this one, times the common ratio, put to the 10th term minus the third term, right, as an exponent, 10 minus 3. So a sub 10 is equal to 1/10, okay, which is my third term, times my common ratio, put to the 7th power, and that gets me this value. Okay. Last example, here I'm given the 6th term and the 10th term. I want to find the 15th term. So to find the common ratio, again, I'm going to take the 10th term value divided by the 6th term value. So 1/4 divided by 4 gives me 1/16. I'm going to put that 1/16 under a radical, where this index is going to be the difference in terms. So 10 minus 6 is 4. So I'm going to take the 4th root of 1/16, which gives me 1/2. So that's my common ratio. Alright, so to find the 15th term, this time I'm going to use the 10th term as my initial term, times my common ratio, put to the 15 minus 10 power. 15th term is equal to the value of the 10th term, times my common ratio, put to the 5th power, and then when it's all said and done, it gives me my 15th term value of 1/128. Alright, that's it for today. So again, if you have any questions, please contact me. You guys have a great day.